Hello students, I was discussing about the classification of instructions based on the length of the instruction. So I was discussing about 1 byte instruction and I gave you an example of instruction MOV A comma V. So to be more clear, I have written it here. The instruction, the opcode of the instruction, and you can say the machine code of the instruction, and how the instruction gets stored. It gets stored in the memory in this way. Each memory location is of 8 bits and the address of the memory location is of 16 bits. So these are written, if I have used H78H, so H represents the hexadecimal format. H is for just for representing that I have written in the hexadecimal format. That's why I have used H here. Similarly, for the addresses also I have used H for representing that they are written in the hexadecimal format. And when you going to convert this hexadecimal address into the binary form, you will get 16 bits. So the addresses are of 16 bits and the memory location of each memory location of the memory is of 8 bits. So those instructions which occupy only one memory location are of 1 byte. Or in very simple terms, let me tell you, there are those instructions where there is no hexadecimal number along with that instruction. When you see an instruction and you do not see any hexadecimal number along with that instruction, means that instruction will be of 1 byte. As you can see, MOV A comma B, or you can say ADD B CMA. So these instructions do not have extra hexadecimal number along with them. So these instructions are of 1 byte and they are represented by their opcode only. The next classification is 2 byte instruction. So a 2 byte instruction includes the opcode and the 8-bit data or address. For example, MVIA 05H, this instruction has the opcode as well as the 8-bit data mentioned on the instruction, and the 8-bit data is 05 written in the hexadecimal format. Similarly, it can have 8-bit data written on the instruction, or it can have 8-bit address written on the instruction. As I've already told you when I was discussing the features of 8085 microprocessor, that the input and the output ports of the address of input and output ports of 8085 microprocessor are of 8 bits. So here IN01, so 01 is the address of the input port. So either the address or 8-bit address or the 8-bit data are mentioned along with the instruction, and these type of instructions come under 2 byte category. What happens? Let's just take an example, MVIB05H. So this instruction has the opcode 06H. MVIB05, MVIB comma data has the opcode. This instruction has a opcode 06H, which tells the microprocessor to copy 05, to move the data 05 into the register B. And when you write the machine code for this instruction, how you will be writing? It will be 06H is the opcode, and 05H mentioned on the instruction will be the operand. Which means when you're writing this assembly language instruction, how this instruction will get, how you're going to enter the instruction in the microprocessor, or you can say how this instruction will get stored in the memory. First, the opcode of the instruction will get stored in the memory, that is 06H, and next any other hexadecimal number which is mentioned in the instruction will get stored in the next memory location. So as you can see from here, this instruction is occupying 2 memory locations, and each memory location is of 1 byte, means this instruction is of 2 bytes. Since this instruction is occupying 2 memory locations and each memory location is of 1 byte, so we can say this instruction is of 2 bytes. And in very general terms, I'm discussing that any instruction which has 8-bit hexadecimal number mentioned along with the instruction, those instructions will come under 2 byte instruction category. The next classification is 3 byte instruction. So a 3-byte instruction includes the opcode and 16-bit address or data. This type of instructions occupy 3 memory locations. For example, LXI 2050H, STA 2051H. So here I have taken another example also, like LDA 2500H. So when this is the assembly language instruction, when you going to enter the machine codes for this instruction in the microprocessor, how you going to enter? First you going to write the opcode. First you going to enter the opcode, which is 3A, all written in hexadecimal format, which is 3A. You're going to first enter the opcode of the instruction, then you're going to enter all the hexadecimal numbers which are written on the instruction. And how this instruction is going to get stored in the memory? First, the opcode of the instruction will get stored in first memory location, and then the lower byte of this 16-bit, the lower byte of this 16-bit data or address will get stored in the next memory location, and the higher byte of this 16-bit data will get stored in the next memory location. Since this instruction is occupying 3 memory locations, this instruction is occupying 3 memory locations, and each memory location is of 1 byte. So we say that these instructions are of 3-byte instructions. So for recognizing 3-byte instructions, all you have to see those instructions which have 16-bit data, or you can say 16-bit data mentioned along with the instruction. Those instructions will come under 3-byte category. How 3-byte? First byte for opcode and the 2 bytes for the 16-bit data mentioned on the instruction. So here we have again completed another classification of instruction of microprocessor that was based on the length of the instruction. The next classification that we will be discussing will based on the operation. I'll discuss in the next video lecture. I'm ending this class here.